All right, so we'll proceed with today's session. So yeah, we'll discuss a few topics which we talked in our last session, which are pending on our uh, on the entire agenda which we had planned for these sessions. So first being uh, dealing with semi-structured data in Matillion. Let me open the Matillion instance. So on Friday, we had discussed one scenario where we were able to pull a certain JSON file through API into our Snowflake table. So that was a use case of getting the semi-structured data into Snowflake. So today we'll see around that how many other ways are there to first pull the semi-structured data into uh, our staging area. And once we have that in our staging area, which is in our case is Snowflake. So once we have that there, how are we able to uh, handle that semi-structured data? So we all know we can do that on our cloud data warehouse, be it Snowflake or Google BigQuery or Redshift, but we'll explore how we can also do it on Matillion. So let's go to a project. All right, so there are a few ways to first get the semi-structured data into our staging area. So one is certainly through an API call, like establishing that endpoint with the API. And once that endpoint is created, we can uh, get the semi-structured data loaded to a Snowflake table and work on that from there onwards, like once we have that in our cloud data warehouse. But let's say if we have a file, a semi-structured data file locally with us, then how can we use that and pull it into our staging area? So that is first scenario we'll be discussing. So let's import a JSON file which is already there in our local. So this is an example file which we are trying to pull into the Matillion. So this is the file name. So as soon as we do the import of that file, we see that it opens this properties pane. So here it is giving us the name of the file and it is asking us uh, whether it can create the job directly on top of it or not. So what it is going to do is that it will create the orchestration job. Why it is an orchestration job? Because it's blue, we know it. And anyways, we are like pulling the data from source. That means, I mean, extracting the data. So it is going to be an orchestration job. So it is going to create an orchestration job on its own directly when we are pulling, when we are importing that file locally. So let's select the jobs and let's all of these features are not here as of now because we are working on default version. We are not like working on any uh, specific version. Uh, We don't we don't have many environments here as well. So that also. So let's just create this job and see what sort of job it is created. So we see that this has created a job, an orchestration job with an SQL script component. So start an SQL script. Let's see what is there in the SQL script component. So in the SQL script component, it has created a query on the basis of that source file. So it is first of all creating the table, and secondly, it is inserting the data into that table. So it is using this SQL statement to do that. So we'll just do OK and we'll run the job. So it is able to create this a new table with this data. So we can also see the SQL statement it was using from here as well. We can also verify that whether that table is created in our Snowflake environment. So let us quickly do that. First, we'll check which environment we are using. So test environment is selected, and we just want to see that which warehouse database and schema it is using. So it is on the loans. So let's go and check in the loan schema. So we have this Brazil 2014 table which is created, and it is just having one column data value and it's of variant type. So we are able to see that, okay, by just importing that file, Matillion automatically created this job, and it used this SQL statement to create that one column data, sorry, one column table. So this data we are able to pull it into Snowflake, but it is not like nested so far. It is a single file in just one column it is stored. So this is the table name which is created, and this is the column name of variant type. Now, if you want to see that what is the data in there, then we can go to a transformation job and use table input component to see that what sort of data it is having. So let's create a new job, Brazil JSON. So in this one, we'll just try to see that what data is there in that table which we had just created using the file, the JSON file. So we'll configure its properties. So Brazil 2014 is the table. It's only having one column. We know that. Okay. And we are going to sample it. So here we can see that it was able to load entire data into one column. And it was 64 rows. That means 64 elements were there in that in that JSON file. So it was able to create 64 rows, but it only pulled the whole data into one column. It didn't segregate them or anything. It just direct load. So that is the one way to do it. The second way, which we had already discussed on Monday, so that was to make an API connector and use that API connector to pull that data, any type of JSON data or XML data, semi-structured data we just pulled in, and we created a new table on basis of that as well. So if you want to see that data, I guess that was different project. Let me see, AccuWeather is here or not. No. So let's see if we want to see that that AccuWeather data as well, that how that was loaded. So we'll just use a table input component to see that how that API component created the table. AccuWeather location was the table name. It's also having one data, sorry, one column, because we had directly just imported that data from the API and loaded into like table in our Snowflake environment. So if we sample this as well, we would see that only one column is there, but it would be divided on the basis of elements. So it is one element, then two, then three. So similarly, we are having 52 rows here. So that these are the two ways we can import it. There is one more way by which we can do it. Let's say if we have a semi-structured data file on our S3 bucket. So how are we going to pull in that case? So we'll see that scenario as well. So let's create an orchestration job, API S3 sample. So, so in this scenario, we are seeing that what if we have a semi-structured file on our cloud storage and we want to pull that data into our Matillion staging area. How are we going to do it? So first of all, we would create a table to accommodate that new file which we are having on our cloud storage. So let's just create a table. It's going to be a new table, so we'll just name it Brazil new. We are making it permanent. We'll just create one column because we know when we are pulling the data from JSON, initially it will not be nested. It will be just one column or data, one column table will be created. So we are just creating that table. And where do we want it from? We want it from S3. So we do S3 load. We select the bucket location. So target table, it is not coming here because we are not sure that because we have not created this table yet. We have just set it up. So we may want to run this component. So let's run this component. We just ran the component. It's successful. It was able to create this Brazil new table. So before that, we would also select the file. Let's go to S3 and see what is the name. It is of JSON type, so we selected that. We are able to see this Brazil new table now. So looks like we are good because the stages are in green color. That means they are validated. So we'll run the job. What did it say? Table already exists. So it is saying that this table already existing. So what we'll do is just simply replace instead of create and then run job. Okay, so we are able to create this new table, Brazil new. We can also test it here that whether we are able to see that data in this new table. So it is not having any row as of now. So so this is of varchar. We want it to be variant because we are loading a JSON file.
Anshuman,
Yeah, tell
are
me.
you sure the pattern refers to the file name? I
Yeah,
mean, pattern can be like when we are selecting the rows in that file, the how so many rows are there. So we like when I was like writing in Snowflake, when I'm creating any file format or anything. So there's a pattern. Like when I'm staging the files, so there's a pattern. So I put dot and asterisk, which means I have to select all the files that is in the stage. So I guess pattern is that, I guess. Regular expressions.
yeah, we can try that. JSON file format can only produce one and only column of type variant object or array. Use CSV file format. So it is looking for all the files on the bucket. We don't want that. So we, yes. So it has been able to create that table successfully. So you were right, Abhishek, if I am right. You were asking right. So yeah, but when we were giving the asterisk, it was taking all of the files which are here and was trying to load them. But that's not the case. We want a JSON file because that's what we are loading and in new table. So file format also we had set. There are a certain number of files which we can load through S3, but in this case it was JSON. So yeah. So these are the three ways which we can um, pull the data inside our cloud data warehouse from an external source when it is semi-structured data. So once we have pulled it inside our cloud data warehouse, then we can start working on it to flatten the data and to get into the elements of that file and like divide it further so we can flatten it and kind of make it in a columnar format. Any questions so far, guys?
Like so when I have created a JSON, like I have pulled a JSON file,
Mm-hmm.
and when I'm looking into it, like it is the kind of unreadable, right? Because it's just one column, and there are all like dictionary values. So like when I'm how to flatten, like how should I see the data in a like in multiple columns? When I know when we do it in SQL, like we have a we have a JSON file in a stage, and then we pull it. And then when we see it on Snowflake, and we use flatten and parse JSON, and then we can see it in multi row, multi column
Correct.
format, right? So can't
Yeah,
we do
that's
that
what
here?
we are going to. Yeah, that's what we are going to
So we are
discuss.
going to, okay, okay,
Yeah,
fine.
yeah, yeah. So we know, okay, so you are saying this is the kind of data it generally. generally shows. Sorry. So this is the kind of data it is showing. It's not
Yeah,
really
so
readable, and
now
we want to
we
divide it.
can make six columns: country ID, English name, and these are the
Correct.
column name, and then we can put like that, like the how
Yeah,
we do flatten and parse JSON, and then we write the value, and then
correct. So yeah, we have component. I mean, that is the next part of handling the semi-structured data. So once we have got the data into a cloud data warehouse in its raw form and just one column in our table, we would want to flatten it. There are several ways to do it. I mean, we can do it through Python, we can do it through Snowflake externally. But when we talk about Matillion also provides certain components which we can use. So one of the component is extract nested data. So we can use this component and we can extract the nested data, whichever is there in the source table. So we would go to the properties. Sorry, we would go to the properties of this component, and we would like try to see that how we can uh, flatten it. So first we want to see that how the data is already in that file. So let's autofill and see that what is the so it is how so like this is how we have this data. So uh it is quite simple data. We are not having many layers inside it. So let's say we want to use all of these component and we want to see the sample of it once we use this component. So if you are able to see, we are able to flatten it. Don't worry about this data value column. That is the first column and that is a property which we have created. So let's say we want to
hello.
Hey guys, can you hear me?
Yeah, I thought it's my network. Okay. Yeah, yeah. We lost you there.
No, it was my network. It was my network. So basically there was a power cut, so it disconnected. But yeah, I'm back.
Bangalore.
So let me, yeah, it's if you see here, it's like heavy thunderstorms, which is happening
Yeah, I'm
since
also
morning.
facing the same thing. Power cuts and stuff.
Yeah, it's raining heavily today.
Yeah, it's actually
Okay,
raining
so
here.
yeah, I was just saying that how we can handle that. Yeah, yeah, yeah. So I was just saying that how we can handle the data. So there's one component, I mean, which is there in place, which is to use extract nested data component. So that way we can extract the nested data and we can use it.
So the output of the nested data. Hello. Am I audible?
Sorry, guys. So yeah,
Yeah. So the output of the nested data is basically a table, and we can use that, right?
yeah. So it is a columnar data, but don't be confused by this first column. So that is just a property which is asking us to include input column as it is. So we know input column is just one column, and we have set it to yes. That is why it is giving us. But if we set it to no, and then we go and sample the data, we would only be seeing the data in the columnar format. So that's a way to do it. Uh, that's how we can use extract nested data. Uh, that's one way to handle it, but extract nested data will not work if the data in our source is uh, having more layers. So here it is simpler data that okay, we just having one uh, master element and like inside that we have column value format. But sometimes we have JSON data which is like in the master element inside also there'll be some elements and then inside also there will be some. So in those case, I mean we will not be able to use extract nested data because that will not be extracting the entire data for us. So we can just see an example. So no, not bank data.
Can't we
Grizzly.
use it twice, like that extract nested data, if there will
Yeah,
be
yeah,
more layers?
we can do that. That all, like that is also one way to do it. But then it will be like using it two, three times or four times or five times according to the requirement, according to the data we are having. If there are more elements in there, then you may have to continue using that. So there's a workaround that as well, that we can instead use another, like component, which will be easy. So we'll just discuss on that as well.
Okay.
So if we are going to see for this one, and then if we are going to go to the nested data autofill. So in this JSON file, we see that, okay, the data is not very flat data, but there are a list of elements which are going to be there. So let's just uncheck most of them and just see if we are going to keep one or two, and see how will we see the data in this scenario through flatten nested data. Let's keep this, keep this, let's keep this in these single columns, and then we go and sample. So if you see here, for certain columns which were not like classified further, we are able to see directly, but for others which have other more number of granularity in terms of the elements, we are not able to really flatten them completely. So in those scenario, we may have to use another component, and which is flatten variant. It's quite similar to what we have in Snowflake. So we can use this component in those scenarios. So I'll use a different, let's create a job using flatten variant. So I have just showed you a few ways where how we can pull the data directly into our cloud data warehouse. But sometimes we are given just the SQL queries, and the SQL query having the the semi-structured data. So we should know how we can read that as well. So for that, we can use SQL component here. So this SQL component in the transformation jobs can be used to read any of the SQL queries. So I have this SQL query handy. I'll just try to read this query from this component, and before putting it into the component, we can just run it and see that what sort of data it is having. So it is having all of these rows. Some are single uh, values which are like key and value pattern, but there are certain uh, rows which are like having more number of elements. So we just use this as a source, and then we would go with our aforementioned component flatten variant. So flatten variant will use. So flatten variant, how it is different from extracting the nested data is that it provides us the functionality of column flattens. So the column flattens is nothing but just providing us a value, a functionality by which we can go into that granular elements and call the like call columns directly from there. So we'll just see through an example. So first, let us see what sort of data we are having. Okay, so sequential key path. So we can go inside this one, this, and inside this we have city. So first layer is this, second is city, and then we have the column value. So attraction name, then attraction name. So we can go inside this. So we will try to set the flatten variant property here to handle these two levels of granularity in terms of elements. So We want to go inside this, and the property is, to go back to see the name. Sorry. So property is city. So I'll just copy city properties. So we want to go inside here. So just give it, it asks for an alias, just how it is set up. We'll give an alias. Okay. And now if you want to call the columns, let's call the column first directly. We'll call the column which are like straightforward. So we'll just call key, and inside key also you have to see what sort of data we are having. So key is directly having one value. It is not having the key value type format. So let's mention it as key varchar. And then secondly, we just created a new alias which is inside this. So we'll use this alias here. So use this city, and we'll alias it as key. Validation error, SQL compilation error. So we can go and see the SQL, that what SQL it is created. So we know that internally, like Matillion is working on top of SQL. So whatever we are doing in like on all on these components is getting translated to SQL. So we can see in the query as well that if it looks good. So it is pulling key city from this city. So I think we should be good if we just put city alias. So we are not able to see the rows, but data is coming. There should be some name. Uh, we we like would have written the name wrong. So we just want to see that this city attraction. Okay, so we want to call attraction inside city alias because that's how the mapping is. We have set this alias here, but here we want to call attraction. We were just calling city, so obviously it will fail. So here you are able to see that, okay, we are directly able to go inside and we are able to see the data here, that how it is. But if we want to divide it further, then we may have to use Snowflake because it only provides us functionality to go deep into the last level of the granular element. But if the data is also uh, differentiated there, then we may not be able to do it, and we have to use SQL component or Snowflake external component, or any of the cloud data warehouse we are using. But we are able to see that when we were having a data which was uh, having the more number of granular elements, we are able to divide it. So we were able to come inside this city attraction and we were able to get this data. So similarly, we can pull the name data as well if we just set it here and add one more column. So we have created this alias, a city alias, and we want name inside it. So we should be able to get this as well. Yeah, so we are able to get so yeah, these are the two component which we can use to flatten the semi-structured data, specifically JSON data, which we are referring here. And yeah, the initial step is to first get that data into our staging area, and once we have that data into staging area, we can work on top of that data and do some sort of transformations on it. We may use the like we may use our cloud data warehouse directly as well, but if we want to explore that how we can do it in Matillion, that's how. So these are the two components. So this is how we handle semi-structured data. Any question on this, guys?
Yeah, can we only in that tool, can you only put columns which have multi levels of granularity? Or we can put, like, for example, there were some columns that was normal, I mean, which was not
It
even granular.
no,
So,
we can pull
and it
that
will
as well.
will it show like the output of the earlier one was a tabular form, everything was able to see. In this, is it like we can only see the those columns which have multi-level granularity,
No, no, we can see the direct ones as well if we.
but we have to put it like in properties, we have to keep on
Yeah,
putting adding it.
correct. So let's use it because this one is not having any granularity and we want to see if flatten variant works for it. So we may not have to set any column flattener here because the like data which we are having here is already quite flattened. I mean, there's no, sorry. So this is calling different table. We want to change it to AccuWeather, and we know that AccuWeather is just having a straightforward data. It's not granular data at all. And we want to see that whether we can use flatten variant to pull that data. So we can just pull ID. I think ID is one column. We want to be sure of the names which we are giving of those columns in the JSON file. Otherwise, it will not fetch. So let me sample it. Okay, so we have ID like this, and we have country ID. So we are able to get the data which is not granular at all as well. But if we are having a straightforward data, it is better to go with extract nested data because that is that component is actually built to handle uh, that kind of data. But if we are having the granular elements, in that case, flatten variant is more advisable. So we are able to do same functionalities using both of them, but we cannot go deep inside any of the elements inside when we are using extract nested data. But when we are using flatten variant, we can do it. So yeah, that's how we handle semi-structured data. I hope this answers your question, Abhishek.
Yes, Anshuman, thank you.
No worries. Any question, guys? All right, we'll take that as no. So let's move to the other parts which we planned on discussing. So which project we are. So yeah, we had discussed briefly about variables, that what sort of variables Matillion has. So we know there are four type of variables Matillion supports. Those are uh, first is the inbuilt environment variable. Second is the user defined environment variable. Third is the grid variables, and the fourth is the job variables. So we talked about job variables. So job variables are nothing but variables which we can define to the value which we have to manually pass. So instead of manually passing them in a project, and we talk about best practices in that scenarios, we don't want to use the manual approach that we are typing the database name, the file names manually, but we want them to be called through a parameter or a variable. So in that like in those scenario we use job variables. The only drawback is that the job variable is only job uh, specific. It will not work on other job. It will only work with one job, and we may have to create them for each jobs. So that's about job variable. Second is the environment variable. Inbuilt environment variable. Okay, so as the name said, those are the variables which Matillion has already like provided in each project. For example, project ID, job ID, report ID, all of those like common variables which are used for the audit purposes. So those are there already. So those are inbuilt one, but we can create our own like user defined job variables as job variables. Sorry, not job variables, environment variables as well. So the major difference between job variable and environment variable is that the job variable is only specific to that job, whereas whereas the environment variable works on all of the job in that project. So if we are having a environment variable in our project, we can use it on in like all of these jobs which are there in that project. So that's environment variable. Second, or sorry, like third, and the last is the grid variable. So the grid variable are basically the 2D array variables. So generally, a variable has a key and a value relationship. Like that's how they are. But when I talk about grid variable, those are more like 2D arrays. That means that they are like list of arrays, and inside that list, they'll have that key and value relationship. So that key would be the name of that variable and the value would be that what value it is having, but that like entire thing would be like packaged in in an outside array. So we can so like whenever we are calling that grid variable, we would be able to call whatever inside that grid variable is having. So we'll see the practical approach of it to see how we can work around it. So let's create a new job. Variables. So we are creating an orchestration job. Yeah, also simultaneously we'll discuss about the iterators. So iterators are nothing but the loops which we have in our programming languages. It is same as loops, but the only thing is that they work on top of variables. So whenever we want to perform some looping activities on the basis of variables, we use iterators, and Matillion provide a certain type of iterators like fixed iterator, table iterator, grid iterator, loop iterator. So the name only shows that what they are. So the fixed iterator would be a iterator for a fixed values. So first, if we like define some fixed value for our uh, variables, and if we use fixed iterator component, it will run for those values. Similarly, grid iterator would be which will run on top of grid variables. As I said, grid variables are having list of values more like an array. So for all of those values, it will run. Similarly, like table iterator would be like like just running for some data which is there in one table. So we may not use the huge tables like $1 million, sorry, like million rows in a table, not those kind of tables, but some quantitative information tables which are having only the facts, and we want to run uh, an like like one sort of iterative uh, like job on top of that. In those scenario, we'll use table iterator, and loop iterator is also pretty much same, that it will run from one value to n value, like whatever is the loop limit we are setting up. So we will go through them. We will understand variables and iterators. So let's create a job. Let's create a table here. So we'll use create table component. So if you see here, it is asking for the values on a different component like database, schema, table name. So all of these, now it is saying that it is going to use environment default. But if we are going to make them parameterized or variabilized, then in that case, we'll create a variable for these values so that we don't really have to manually type them. So here we are using environment like default, because we have these environment set, and whatever is the default value these environments are having, it is going to create this table there. But we don't want it to use that, but we want it to use through a variable. So first we'll create a job variable, because we're working on a job and we wanted to use variables. So we saw that it is asking for database and it is asking for schema. So let's use variables to provide these details in the job. So we can provide the database name. So which, let us see where we are. We are using test. Test is selected. So we are using this environment. So we would see what are the properties. Okay. So bank loan DB and loans. So we can set that as default value for this variable. So it would be bank loan DB and schema would be loans. So we have set it up here. And now when we are using this component, we can use variable instead of using the directly the environment default value. So for database, we had created the job variable, so we can use that. And for schema also we have created. So use variable and then we can use schema. So here you see there are a lot of variables already existing, like component ID, component message, component name, environment, default schema, environment endpoint. So these are the predefined environment variable which are already there, which helps us in audit purposes a lot. So here, when we are using the job variable, we'll simply use those variables and we'll give the table name as example. We would create some input column, column 1, size 20. The column, the component is validated, so we would simply run this component and we are able to see that the table is created and we did it through the job variables. So whenever you're going to work on any of the project, you would see that everything would be variabilized. Nothing would be manual. And even if it would be manual, it would be advised to make it call through variable, because it comes into best practices of ETL coding, that we have all of these components parameterized or variabilized, both synonyms. So yeah, that's how we can use the job variables. I'll remove those job variables too. Now let's talk about environment variables. So environment variable are nothing but job variables, but for all of the job in that project. Okay, so let me create an environment, manage environment variable, and I'll create them. So database schema. So as you see, it is coming for two environments. So why they are coming for two? Because here we have two environments in this project. So whenever you are working on a project, there would be we'll be working on a number of environments. One would be dev environment, one would be like testing environment, and one would be like production environment, for example. So we would have different values of these databases and schema, or any of the variables which we'll be having, the values will differ. So when we are setting environment variable, we can set it for each environment as we want it. So that functionality is not there in job variable, because those are just job, like job level variables. But these are going to be environment or like project specific. So whatever environment that project is having, will be able to set the environment variable for them. So we are using test, so I'll just set it for test as of now. So it was loans, I remember that, and it was bank loan DB. So I'll go and change these and use the environment variable. And I'll make create replace as replace because I have already created that table. If I'll run it again, it will give me that table already exists error. I don't want that, so I'll just replace that and I'll run the job. So the job was able to create this table using the environment variable. So that's the functionality of job variable and environment variable. Very similar, but only slight difference. One is project specific, one is job specific. Now let's talk about grid variables. So grid variables, as I said, are 2D, like 2D array. So they are having a list inside them. So let's create a grid variable. So we are working on creating a table. So I'll just create a grid variable related to that. So I can name it as table details. We have talked about the behavior, copied and shared. I'll just repeat. So when we say copied behavior, that is more like local. And when we say shared behavior, that's more like global. So like copied is only specific to one version. So whenever we'll be working on any of the project, we'll most likely be creating our own versions. So if we are creating a variable which is copied, it will only work for that version. But if it is going to be shared, it will work for all of the versions inside that project. So we can, to like simplify, we can understand them by as like local and global. So I'll make it global or shared. So as you see in other variables, it was simple that if I was giving a value, if I was giving a key, I was supposed to define its value. But here I've just given its name. So this is more like the name of that array. And it is asking us that what value you want to save here. So we'll just add the columns. So we can have any number of columns in a grid variable, which we can use um, inside our jobs. But again, grid variables are also job specific, so we may not be able to use it in another job. So uh, we have to create them again. So yeah, I just gave two values. So like that's how it is different from other variables that here we can have a number of values inside it and we can use them. So now I'll set the values of them. So database schema. I'll just set the values. Bank loan DB, loans. That can be the first value. And second would be adventure DB. And schema is this. So this is how a grid variable is created. So a grid variable inside this table detail, it is having these two columns, and these two columns are having these two values. So whenever we are going to use this grid variable, we are like we'll be able to use it for all of these values defined. So it is different in a way that in other variables, we can just use a single key and value format, but here we can use a list. That's the major difference. Um, and there are certain ways to create it, either by right clicking on this canvas and using manage grid variable, or from here as well, we can create it. Uh, Sorry, from the job only we can create it. Manage grid variable if we want to create it in a job. So once we have created it, how we use it. So Let me first set my environment variable. Let me remove these values because I want these values to come from the grid variable. So I'll empty it out first. And so now the functionality which we can use is like grid iterator. So we know what iterator simply does. It is nothing but a loop. So it will run from one value to another. So if I will use a grid iterator here, that means it will run for both of those values which we have given. So both of those databases and both of those uh, schemas. So let me search grid iterator. And iterators generally are going to sit on top of a component. Why? Because we know that they are going to run that component from one range to another range. So they are always going to be sitting on top of a component. So we have to connect them to that component and they automatically comes on top of that component. So let's set this grid iterator value. So it is asking which grid variable you want to use. We want to use table details, and it is asking that for what variable you want to use it. So that was the grid column, and that is that environment variable column. So we want the database grid columns value to be passed to this environment variable so that we can call it into our create table component, and that create table component will have the value which is there in the grid component. Similarly, we want to do it for our second uh, column in our grid variable, and we want to map it to the schema environment variable so that whatever value is there in this schema grid column will come to this environment variable. So we have set the grid iterator. Now we want to set the create table properties. So we want to use database. We want to use schema. Parameter contains error. What error is this? Database input required, schema input required. Okay, okay, new table. That's fine. Iterator, database. Let me just change the name a little bit. Okay, so I think we may have to run this component first so that there is some value in these variables, environment variable, which we are trying to use in the create table component. So let me run this grid iterator component so it puts the value there and see if that works. Run. iterations generated. It was able to generate the iterations. First was this. Second was this. Create table. Okay, it is giving an error because we are trying to point to an environment which is not selected as of now. So if we see here in the edit environment, we are in this environment, and in the grid variable we have given the value of another environment. If you see manage grid variable values, adventure db and aw data lake, which are not in this environment, so we may want to give a value of some other environment here. So we'll probably use this snowflake and core, place name in the sql. Okay, so those are in different roles, different warehouses, both of them. So that is why I believe it's not able to use the second one. So I'll try to use a one which is in the same warehouse. So now I updated to this. Okay, run component. Now again the same error. Creating table on shared database. Snowflake is not allowed. So we're not having permission here.